All right, so back to data. Now, hopefully we're getting the idea of the difference between a case and a variable. A case has a bunch of variable values that go with it, and a variable has a whole bunch of different options. Now, there are different kinds of variables that we need to look at also. So types of variables. So here you can see we have a NO, which stands for number, and a POS, which is position, and a player, and a birth date, and so on. We can pretty much categorize variables into two different types: categorical or quantitative. So categorical are things like my name, I'm Gary, I'm a male. Those are categories I fit into: the name Gary, the idea of being a male. I'm a teacher, right? That's my profession. I like to mountain bike. That's another categorical thing about me. Some quantitative things about me is I have a height, right? I'm 174 centimeters tall. I weigh 74 kilograms. I'm 51 years old this year. So when we can apply a number to something, it's quantitative. Oops. Categorical is more like the name of something. Okay. So if we look at these variables here, we should be able to distinguish between which ones are categorical and which ones are quantitative. Now, sometimes things can be a little misleading. So for example, this number right here, that is just like, number 1 on the field, that's just another name for Alyssa, or number 2 is Mallory. So this number that I'm using over here, their jersey number, that is really just a categorical thing. It is a name. So the number is like a name, that's categorical. The position, that's definitely a category somebody fits into, whether they play forward or goal or midfield or defender. So that's definitely categorical also. Somebody's name, definitely categorical. Date of birth. Now that really is a number, right? April's a particular month. There's the day in the month. There's the year they were born in. So this, I think that's going to fall into the quantitative or number idea of a variable. Age, definitely quantitative. Let's see, CAPS. What does CAPS stand for? I forgot. I know some of you are soccer players in my crew here. CAPS.
It's more like appearances.
What is it?
It's more like appearances, like how many games you've played.
Oh, is it? Okay. So that, yeah, that's definitely a quantity. Goals is definitely a quantity. And club, definitely a quantity, right? And it matters because there's different kinds of things we can do with a categorical variable or a quantitative variable. So for example, for the age here, I could definitely find the average of the ages, right? That's something I can do with a quantitative variable. I can find the average number of goals scored by these. Oh shit, club would be categorical. Why did I write quantitative? I guess I was on a roll with writing quantitative. Definitely not quantitative, that is categorical. Thank you for straightening me out there. Now, it doesn't make any sense, however, to find an average name. How would you even do that? Average is add them up and divide by how many, right? So I can't find an average of a categorical variable. Now you might say we could find the average number of the jersey, but what does that even mean? Like think about other numbers that aren't really quantitative. So this is an important note. Some numbers are not actually quantities. So some examples. Now we clearly just looked at one, someone's jersey number on a team. That's definitely not. I live in Pendleton, Oregon, which has a zip code of 97801. Right, that's just another name for this place. My mother lives in Rhode Island, right? So this one is Pendleton. I grew up in Rhode Island, a town called Smithfield. And that one is 02917. And often when we write numbers, if there's a leading 0 on the left, we don't even write it. But the zip code, it turns out it is important, right? Can anyone else think of a number that we use that isn't actually a quantity? It's more like another name.
Social Security?
Yeah, Social Security number. Right, so it's usually what, 1, 2, 3, and another 3 numbers, and then another 4 numbers maybe. License plate, yeah, license plates are often numbers. Sometimes they're letters too, so that's a good one. Social Security number, oh, it's 324, right. I haven't thought about my Social Security number in years. All right, thank you for straightening me out there. And again, I'm human, I make mistakes. Feel free to straighten me out, like my horrible spelling. It's funny, for a lot of words I know I'm going to use in class, I try to write them down, make sure I get the spelling right before class, but in the heat of the moment, I generally screw things up. So yeah, there's license numbers. You got a student number, right? Your student number is a number, but it's not really a number, it's just another name for you. So we do have to be careful about that. Those are called nominal variables, and it just means it's a number, but in name only, okay? An important thing, so these are really categorical. What about numbers and formulas? Yeah, so like we couldn't use a Jersey number, a zip code, or Social Security number in a formula. We would need a quantitative variable to use that in a formula, like age, or the year of somebody's birth, the height of somebody, the weight of somebody. Those things we can use in formulas. But generally categorical variables don't really belong in formulas. But there are a few things we can do with them formula-wise, and we'll get to that. So these are really categorical. But I can do things with them. So like with categorical, I can find, for example, the most frequent value. That actually has a name in statistics. It's called the mode of the data. And we can have a mode. There can be a most frequently occurring zip code with the students in my class. There could be like a color is a category. There could be a most frequently occurring color of eye, or color of hair, or favorite color. So that's one thing we can do. And the other thing we can do with categories is proportions. So what percent of the class has the zip code 97801, right? So I could look at all the zip codes and say, hey, it's about 40% of the class has a zip code 97801. So proportions, which is some count over a total, we can do with categorical variables. So there are some calculations we can do, but we can't do a thing like average categorical variables. It just doesn't make any sense. What's the average Social Security number? Huh? What? That's crazy talk. Okay, so let's take a look at some other data. So let's see, what do we have here? So, oh yeah, so this was the percent uninsured, which we'll probably come across this data again. And each of these numbers in here, like 16.9, really means 16.9%. Now then we have the margin of error. And this is an important idea we're gonna get to later in the course. In this case, it is also a percentage. So what it means here is that we think in Arizona, 16.9% of people who live in Arizona are uninsured, but it could be more or less by 0.3%. That means it could be as low as 16.6% or as high as 17.2%. So it's really 16.9 plus or minus 0.3. And we'll get to margin of error later in the course, I think around week 5-ish, when we talk about percentages and other calculations like that. But each of these, again, is a variable. So I have the percent uninsured in 2010, and I have another variable that's called the margin of error for that percent in 2010. These are quantitative variables here in this column, so I could do something like find the average of them. As far as the names, in this case, each of the names is unique, so there's really not much to do there, except maybe I could put them in some kind of order. They're already alphabetical. So sometimes for a categorical variable, there's really not much we can do. It's just kind of a name for that row. And sometimes the name is meaningful, like Alabama, and sometimes it's not so meaningful, like 2. Right? Mallory Pugh is a more meaningful name for that row, but here we have a first one of 2. Is the first column in a data set like the most important name for that? Not really. A lot of times we just number them for ease of use. So we'll get to that in a little bit. All right, variables. Okay, one more thing to say about variables for now. Let's look at a different data set. So this data set's going to come up often. This is a data set that came with our book, and I'll show you how to get to those data sets later. But this is a student survey that a particular university did regularly. And this one, let's see how many are in here. Spreadsheet trick, for those of you who don't use spreadsheets much. If you're in a particular cell, like here I'm in my column A, row 2, there's the word senior. If I hold Control and Shift and then hit the down arrow, it will look for the end of the list. Now the end is up to where the first blank cell is. So you see that's not actually the end. So I can just hold Control Shift and then down arrow again, and it will keep looking for the end. Okay. So here I get to row 363. Now there was a header row. So that means there's 362 cases in this data set. So when we're working with a spreadsheet, we do want to be careful of looking at the row number and saying that's the number of cases, because often there are one or more header rows at the top. In this case, the header row describes the variables. Sometimes there are more than one header row in the data set. So we do have to be careful in terms of counting that way. Often on a spreadsheet, if you select a whole bunch of stuff by using that Control Shift arrow or just dragging your mouse, I'll just stop there for fun. The spreadsheet will often give you some kind of summary. So if you look down on the bottom right of my screen here, you can see it's counting right now. I highlighted 223 things so far. And then some spreadsheets will give you other options instead of a count there, which is kind of cool. If you use Excel, that's fine. I highly recommend Google Sheets. It's a little easier to use and a little easier to share the files. All right, so we got a lot of different variables here. Each row here is a particular student. Now notice we don't have a student name and the students aren't numbered. So we can always add an identifier if we wanted to. But all I can say right now is, for example, this row here is the second student in my data set, according to the way they're listed now. I have their gender, do they smoke, what kind of award would they like to win? Often when you get a data set like this, it's hard to know what each variable means, and often you'll have to look for a key to get more information about that. Like, what does TV mean? My recollection for that is the average number of hours of TV they watch per day. Some people wrote 20, which seems a bit excessive, maybe impossible. All right. How many hours they exercise. This one I remember was per week for exercise. So I might wonder, is there a relationship between the amount a student exercises and their GPA? So another big thing about statistics is we get this data to answer questions. That's really, really what statistics is about, right? We summarize the data, yes, we analyze it, and we analyze it to answer questions. So let's make a note of that. In statistics, collect data to answer questions. So for example, a question I was just thinking about looking at that data set is, do students who exercise more have higher GPAs? So that's an interesting question. So one thing I'd like to put out to you all is, what are some interesting questions you might like to ask and see if we can answer with statistics? And there's two parts to that problem. One is, well, we got to get the data to answer the question, and then we have to get the data in the right way to answer that question. And we'll talk more about that today or tomorrow. But trying to answer questions with statistics. I read a study a while back that if you move around when you're thinking really hard about something, like take a break and get a little exercise, your brain will work better. So the question might be something like, does periodic exercise improve one's ability to think? And I found a study that tried to address this question, and their conclusion was that if a person got up and exercised a little bit every 5 minutes for every hour, that their work was a higher quality than people who didn't. So for example, when I have students take tests in the classroom, I often say, all right, half an hour's gone by, everybody stand up, move around, get a drink of water, go potty, changes your blood flow, your brain settles down a little bit and helps you think better. Let's see, I got a question here. Test scores of those who exercised the week prior versus those who were sedentary. Yes, okay. So we have some excellent things going on here. So a lot of times when we ask questions in statistics, we relate a couple of things together, okay? So in this case, I'm trying to relate exercise to GPA or exercise to thinking, right? Like, how do we measure thinking? In this case, it was measured by test scores, right? The higher the test scores, apparently the better someone thought. Higher the GPA, so on. We have two kinds of variables here that are a little different than the idea of quantitative versus qualitative or categorical. In this case, we have explanatory and response variables. For my first question up above here, let's call that question number 1, I'm thinking that the response is the GPA, and the amount of exercise would explain a higher GPA or a lower GPA. So I was thinking that the explanatory variable is exercise, and that leads to some change in GPA. Okay, so explanatory response. If you think about math classes you did before when you were graphing things, for example, this would be my X, and I use the X to calculate the Y. In a math class before, like in algebra, we would call this the independent variable. We force it to change and then see what happens with the other one. So this one we're thinking is the dependent variable. Sometimes it could go either way. Like, does somebody with a higher GPA exercise more, right? We might be able to ask that question the other way. and maybe something about their high GPA prompts them to exercise. Other times there's a clear relationship that, yeah, this has got to be the explanatory and that's got to be the response. Just because we have two variables that change together doesn't mean they're related, but we're hoping there is a relationship here. And by relationship, what I'm looking at is like cause and effect. Okay. So that idea of cause and effect, we're definitely going to talk about some more. The other idea is when we do have these explanatory and response situations, sometimes they're just observational. So types of studies, there are observational studies. So observational is all we do is observe, we just watch, okay? So like the student survey we did there a minute ago, we just collected that data, right? We didn't interfere with it at all. We didn't say, hey, you students are gonna exercise more, you are not, okay? It's just observational. Other kind is experimental. In an experimental study, we take control of one of the variables. Now we might control more than one, right? We might control exercise and sleep. But often we're just gonna do one at a time, okay? So control the variable. So with that, again, the student survey, that was just observational. We just said, hey students, how much do you exercise a week and what's your GPA? We just asked, observed. Experimental would be we get students to participate in this study, and then we take some of the students and say, okay, you guys are going to exercise this much per week, and you guys over here, you're not going to exercise at all, okay? So we have to control a variable, and that's called an experimental study versus observational. And it's often good to know when we have one or the other. So those are some other big ideas about data. Questions so far? Okay, this is a good time to pause again. So we've been looking at the idea of what is statistics, what is data, and a couple more big ideas that we have to get through. So the sections we've been talking about right now is mostly section 1.1, a little bit of section 1.2, and a little bit of section 1.3. So the idea about observational and experimental studies, that's section 1.3 material. I'm gonna back off just a little bit and take a look at section 1.2 in a little more detail. Again, statistics is about collecting data, summarizing it, describing it, because you can't just look at a big list of numbers or names and get something out of it, right? You got to do some work to make it informative. Getting that data is an interesting thing. So as far as getting data is concerned, collecting data, data comes from a population. And all a population is it's a group of interest. So for example, when I was looking at that student survey that the publishers of our book gathered from students at their college, I was wondering, is there a relationship between exercise and GPA? And so what would the population there be? So an example of a population could be all college students in the US. Now think about that. Could we get the names of all college students in the US? And the answer is not easily, right? How would we do that? We'd have to track down every single college and ask them to give us a list. Would they? No, actually they wouldn't. There's laws against that kind of thing. Now, if we were a governmental agency that made those laws, perhaps then they could get the list, but I can't, and you probably can't either. So this is an interesting dilemma when we are trying to answer a question about a particular population. Can we really get a hold of everybody in that population? So that's when the idea of samples come across. So we have populations and we have samples. And a sample is just a subset of the interest of the population of interest. Now, when we're dealing with samples in statistics, we want a couple of things to be true about these samples. One, we want a random sample. We'll talk more about what random means in a minute. And two, we want a representative sample. That is, we want the sample to be as much like the population as possible. If we are looking at college students and we take a sample and the sample happens to be all females, then our sample is bias. So there can be sampling bias. So let's say beware sampling bias. Sampling bias is some bias based on the sampling technique. Let's call it sampling method because I'm running out of room there. So if I choose a sample in such a way that I get only females, that would be bias. An example of bias I had a few years ago is in classes like this, I often have students do projects, especially in the lab. And usually the students come up with the project, and it involves making a survey, delivering the survey, and then trying to answer questions on the survey. And one group of students was interested in the prevalence of diabetes. And they collected their data and then they reported it to me, and they came back and they said like 25% of the population around here has diabetes. And I said, no way, that's not possible. Something's wrong. Where'd you get the data? Well, Jill collected the data. Where did Jill collect the data? She got it at work. Hey, Jill, where do you work? I work at a doctor's office. Oh, really? What doctor's office? She told me the doctor's name. And it turns out this doctor specializes in diabetes care. And she was just asking patients that came to the clinic for whatever. So obviously they got a lot of diabetes patients. So her sampling method was biased because of the where which she tried to collect it. And she claimed that, yeah, people just kind of randomly come into our clinic. No, they don't. That's not true. So you know, what does random mean? I met up with my sister in the desert of Nevada recently, and she was telling me she met this new guy, and she's like, yeah, I met this guy at this random bar. I'm like, no, you didn't. There was nothing random about that bar. You picked it because it's down the street from your house, and he picked it because he went with a friend, right? It wasn't random at all. So we often use the word random in the wrong way. So we need to talk about what random means. Okay, let's see, I got some stuff in the chat here. Okay, so lots of comments about bias. So there's all different kinds of bias out there. The kind of bias I'm talking about here is just bias based on the sampling technique. There are other ways to be biased. So let's do a side tangent here about ideas of bias. We are all biased because we have beliefs about things, right? I believe math is good. I believe that people should be kind to each other. I have all these different beliefs, and those beliefs bias the way I see the world, the way I do things, and so on. The types of bias we talk about in statistics, sampling bias is one of them. And as I mentioned earlier, and please read about this in the book, that's just bias based on the way the sample was taken. Questions can be leading, and that's a different kind of bias. For example, I might say, hey, math is really hard and most people suck at it, so don't you think we shouldn't have math as a requirement in college education, right? So I'm leading somebody to say, oh yeah, I suck at math, let's get rid of math, right? Or somebody brought up meat, that feedlots stink, and so meat is not good. Or if you write questions in such a way that you're pushing somebody toward an answer, right, that definitely brings about bias. Other kinds of bias are related to the idea of self-selection. You ever get a call and someone says, hey, we'd like to ask you some questions about what you've watched on TV recently, or who you're going to vote for on the next election. And sometimes I say, oh yeah, okay, I'll answer that. And other times I'm saying, yeah, no, sorry, click, or I just hang up, right? So I chose to be in it or not to be in that particular survey. And then the question is, well, why did someone choose to be in the survey or not be in the survey? And each of these things can definitely make the results of the survey and any analysis of it questionable. So that's another big thing is, well, how do you collect data that's unbiased? And it turns out it takes a lot of work and practice to do that. We're just scratching the surface on what it means to make a good sample, to have questions that are unbiased, and to try and avoid bias by self-selection. But these are definitely some ways that results can be biased. And these companies that have statisticians that work on these surveys work really, really hard to eliminate as much bias as possible. Can you eliminate all bias from data? The answer is no. Why? Because we're humans. That's why. We're just biased by nature. But there are ways to minimize it and have reasonable results. And there's a bunch of examples in this of the book that you definitely need to read about this week. Okay, so back here. Oops, wrong way. There we go. So important ideas here is that from a population, we take a sample because we usually can't get access to the whole population. Now, with respect to sampling, the most basic kind of sample is called a simple random sample. So let's take a look at that idea. So let's suppose I'm doing research for college students and I want a sample. So sample of 100 college students. This 100 right here is my sample size. We will have to deal with letter variables like X and Y and stuff. The sample size is usually given the letter N. So if you see an N equals 100, that means the sample size was 100. The sample size might be 1,000, it might be 10,000, it might be 10, right? The sample size can be just about anything we want. If the sample is too small, it's not going to be useful. If it's too large, it's just harder to work with. And later in the course, we'll talk about what's a reasonable sample size for a given situation. So in this case, sample size is 100. So a simple random sample means that all samples of size 100 in this case have the same chance of being selected as any other. So you'll see a similar definition to this in the book. Instead of the number 100, they just put an N there for whatever the sample size happens to be. So if somebody said, hey, I need a sample of size 55, well, it'll be a simple random sample if all samples of size 55 have the same chance of being selected as any other sample of size 55. At the moment, let's see how many people are with me right now. There are 17 of us collected here, including me, to do statistics. Okay. So if we were talking about statistics students, then I have a sample of statistics students, right? I'm still a student of statistics. I'm constantly learning new stuff about it. I get the joy of teaching it too. Now, if this group of people was a simple random sample, then every other group of size 17 of statistics students should have the same chance of being selected as this one. Now, you guys are here not for any random reason, you're here for a very particular reason. So there's nothing random about this group of 17 people. What I have here is not a simple random sample, it's a convenience sample. So if I collect data from you guys and I try to use it, it's not really going to be that useful because it's not a simple random sample. It may not be representative of other statistics students because of the reasons that we came together today. So there are many types of sampling techniques. We're not going to go over them in any detail. I just want to mention a couple for fun. Simple random sample is kind of like the ideal, but you can only do a simple random sample if you have a list of every possible individual. In this case, like with our class collected today, I have a convenience sample. I'm going to collect some data from you guys today. It was very convenient. It was easy to do. I didn't have to work hard at all. I just said, hey, answer this question, and you did. Other times, I mentioned earlier that a sample ought to be representative. Now, representative means a lot of different things, basically like the population. And sometimes in our sample, we want to make sure if the population is 60% women, our sample should be 60% women. And when we try to ensure some kind of proportion based on the categories of individuals in a population, that we meet those, that's often done with what's called a stratified sample. So somehow I would be able to split the population into males and females, and I would select 60% of my sample to be female. So if I had 100 people, I would want 60 women and 40 men, because my population has 60 women and 40 men. Now, often we don't know those numbers in the population, but often we do have a guess. And so stratified just means to split it up into certain proportional categories. Categories. Another common type of sample that's done out there is what's called a clustered sample. And for those of you who have been in college for a little while, maybe at BMCC, do you remember ever being in a class where they had the whole class take a break from whatever they're supposed to be learning so the whole class could do a survey together? And it's a national college survey because we get federal money to help teach you all. We have to follow these federal rules, one of which is to do a survey once in a while. And those surveys, the way they work is first a college is randomly selected, so Blue Mountain, and then Blue Mountain is required to then sample a certain amount of classes. So we randomly pick 20 classes, and for each of those classes, every single student in that class needs to fill out the survey. And so what we're doing there is we're clustering our sampling by grabbing a whole class at a time. So somehow we have a way of splitting up into specific groups, and then we grab certain groups. A classic example, besides the classroom one, of the clustered example for that is, let's suppose we have a town. And that town is going to have neighborhoods. And maybe the town is broken up into a nice grid of neighborhoods. And so the way a clustered sample might work here is we randomly select just some of those neighborhoods. And then in those neighborhoods, every single individual has to be part of the survey. Okay, so there's a bit of randomness in that we randomly select some neighborhoods, but then we get every individual in those neighborhoods to try and get an idea about something in that particular town. So there are many techniques for making samples. The idea of the simple random sample is the only one the book really goes over, but I just wanted to give you some ideas about other types of samples. Stratified might be one of the most popular because we're usually concerned about different gender groups or different ethnic groups. Sometimes we look at groups based on education, like we want to have a certain amount of people that have only a high school degree and a certain amount that have a college degree. So there's lots of ways to stratify a population, to split it up into groups where we want to grab those groups like they are on the population. And the point of talking about those was because I just wanted to help you get a better idea about what this idea of representative means. So two big things when we're collecting a sample, there has to be a random component there and there has to be a representative component. Now, as far as random goes, random is a tough one. So random means chance has to be involved. So there's a chance something could happen, there's a chance something could not happen. Random is not haphazard. So for example, I have a piece of paper in front of me and I'm going to randomly select a letter and this R is just jumping out at me. So I selected this R. It was the biggest letter on the line in the middle. So that was kind of haphazard there, but it really wasn't that random. Humans are not good randomizers. So you can't expect a human to go and come up with a random list on their own. Generally, we need technology for this. Now, there are very simple technologies that might do this. So for example, I could pull names out of a hat. If we have all our names on slips of paper, all the slips of paper are exactly the same size and shape, and they're well mixed in a hat, and we reach in without looking and grab one out, that's pretty random, okay? So we have some chance involved there. It's not me looking at something and doing it, right? So when we look, when we think about things, our biases come into play, and we mess up randomness. So the simplest piece of technology we could do as far as randomness goes is pulling names out of a hat, like shuffling a deck of cards. Okay, that's similar to this one right here. Otherwise, we need a computer. So if you have access to a spreadsheet right now, I highly recommend you pull it out and try this with me. So I'm just going to play with randomness on a spreadsheet for a moment to try and help you get an idea about what it means. And let's make a new one. Oh, so by the way, if you're not that familiar with Google, or if you don't even have a Google account, get one. They're free, right? So you can just go to Google. Let me just do that for fun for those of you who don't, but I think most people do these days. Let's go incognito. So if I go to a blank Google screen, they'll usually have a sign in button if you're not already signed in. And if you don't have a Google sign in, then you can just create an account. And it's free. Just give them a name. What do you want your email address to be? And then make yourself up a password, and in you go to your Google account. Nice thing about having a Google account, new page here, is once you're signed into Google on your browser, then you have access to things like Gmail, which I don't really care about at the moment. What I care about is Google Drive, Google Sheets, Google Docs. Now, generally, I access everything from Google Drive. And in Google Drive, I've got a whole bunch of folders. Okay? And so usually I start in whatever folder I'm interested in, like maybe math classes. And in math classes, I want math 243. And then in math 243, I have a whole bunch of different folders. I'm going to call this good enough. And then from Google Drive, I make a new. So there's this new button up there, sheet. Now, since Google is so searchable, you really don't need to do that. I'm making believe like Google is my computer where I can look on my hard drive for my files. You could, in your Google account, just go straight to Sheets, and then here start a new blank sheet. So you got a couple of ways to do it. Always a good idea to title it. So I'm going to call this one Random Stuff, because that's what I want to play with at the moment. Again, I highly recommend Google Sheets, and sometimes I ask for them because they're easier to share. Okay, so for fun, I'm going to do a couple of things here, put a few numbers in there, and then I'm going to share this with you all. Now, if your Google account belongs to like a high school or another college, when you go to share something, it's going to be restricted to only people in that institution. So what I need to do is I need to change that so that you guys could access this too. And so I want anyone with the link to be able to use this, okay? Now, right now, anyone with the link is only a viewer, which means you can only see it. Okay, so I want to just demonstrate the difference there. So let's copy it. And then I'm going to post this in the chat for anybody that wants to check it out. Everyone. All right, so in the chat now should be a link to this Google Doc. And for those of you watching this in the future, I'll put it in the description of the video. And if I change something there, so if you open this up, so if somebody could play with me here and open up my file just for fun, I'll get a little notifier up here that other people, oh, look at it, we have the anonymous hedgehog in there. Cool, thank you. So if I do something in here, like add something to it, like I'm gonna put in rand function, then every time I do something, you should see my spreadsheet change if you're viewing my spreadsheet. Okay. So as I change the spreadsheet, you see it change. Now, since you're just a viewer, you can't edit it, but I could invite you to edit it too. And you can do that in two different ways. So I'm just gonna call this number and random. And one thing you might notice is that every time I type something on the screen, these random numbers shift. You can copy and paste into your own sheet. Yeah, so there's a couple of ways you could then use my sheet. So often I'll share my spreadsheets with you. So one thing you could certainly do is you could copy whatever I have here and paste it. But a lot of times in my spreadsheets, let me show this one, for example, not that one, this one. I might have more than one tab of information on the sheet. So then it's kind of like if I have 10 tabs, you don't want to copy and paste every one. So what you would do is a couple of things. If you're signed into Google, then you would go to File and choose Make a Copy. Now, if you make a copy, what that does is it takes whatever I have here currently and makes a copy of it. If I add to it in between the time you made the copy, then you won't see the new stuff. You would have to go back to my original shared link to get my new stuff. Okay? But if at this point, since I set it as view only, your only choice is to either just look at it, view it, or if you want to edit it too, you would have to make a copy. Another thing you can do, so let me bring up an alternate version of me here. Let's go to this account. And I'm going to paste that link in. So this is a different version of me in Google. And right now, this is the way you probably saw it, as view only. Now, if you don't have a Google account, you won't even see that view only, right? So if you don't have a Google account at the moment, I highly recommend you get one. Then it would look more like this. It says sign in up here. Well, I guess it does still say view only, but you can't really do anything much here. So let's go back a moment to this one. If you're signed into your Google account, though, you have a couple options. One, you can make a copy of it. Two, you could request edit access. So that would send me an individual message saying, hey, so-and-so would like to edit your document. And either I'll write back and say, sure, here you go. Or I'll say, you should make a copy of this for yourself, because I don't want you to change what I've done. So often when I share a file, I want you to make a copy of it, because I want everybody to have the same starting point, is what I'll do. And I'll share some more reasonable ones later that are going to be useful. Okay, so let's play some more. Again, if I wanted somebody to have edit access, I have two options for that. So let me get back here. If I go to share, I could enter their email address here, and that would invite them to edit it. The other option is where here I had anyone can view it. I could change it to anybody can edit it. So anybody that has this link can change what I have here. So right now I just did that. So if somebody is on this sheet, if you could click somewhere and type something, there we go, we get a brave person there. Yeah, there we go. So now anybody in the world can edit it. Now I can always revoke that and say, you're done, sorry. All right, so a couple more things I want to show about random. I'm going to turn off that just so we don't have chaos ensue. Put back on view. All right. So as far as the random stuff goes, there are a couple of options in a spreadsheet. Number one, I have this RAND parentheses function. And all it does is generate a random number between 0 and 1. You could get 0, but you won't get 1. But you could get 0.999999999. Now, eventually, the spreadsheet only stores so many digits. So if I highlight these guys and show more decimal places, eventually it's going to run out of digits and just give me a whole bunch of zeros. Okay, so you can see I only have about a dozen digits of randomness to work with here, but that's still a lot. So this is the function, I guess I should edit that, RAND parentheses. Another useful one is called rand between. And there's rand array, which I'm not going to get into here. So rand between picks a whole number between two given whole numbers. So often what I'll do is, like for a class of 16 people, I'll say, okay, give me a random number between 1 and 16. And it said 2. Oops, I wanted that to be down here. And every time I do something on the sheet, these random numbers change, right? So if I go over here and type y, it changes the random number. If I delete the y, it changes the random number. Okay, so that's kind of it's a cool feature of the random number features, but it's also kind of a pain in the butt sometimes. If you want the random numbers to stay the way they were, then you have to copy and paste them. So let me just demo that here. So this one is called rand between. And all of these are what are called pseudo random number generators. Besides nature, there's no really true random number generators created by humans because we're human. And I can fill that down and generate a whole bunch of random numbers. If I want to keep this particular set of random numbers, what I would have to do is copy them. And then when I paste them, there's a couple of ways to do this. Paste special, values only. Instead of pasting the formula rand between, we'll just paste the last set of results. So if I go paste values there, there's my original 12, 6, 4, 16. And notice if I change something, the rand between column changes, but that first set of random numbers does not. Another way that I do this quickly often, like I want to reuse this set of numbers exactly as they are, I'll copy, Control C. And then if you do a Control Shift V, that gives you values only, Control Shift V. If you do just a Control V is paste, by the way, then it gives you the formula. So notice when I click on this cell right here, it says ran between 1 and 16, just as it did over here, ran between 1 and 16. So when we need randomness, we can't rely on ourselves to do it. We're biased. We have to use some bit of technology, whether that technology is simple, like a hat, or we use a spreadsheet to generate random numbers. That's a different thing. Now, something to consider about ran between, it can reuse numbers. Like notice the number 2 appeared several times. The number 11 appeared several times over here, okay? If you don't want that repetition, then ran between is not your friend. You would want to use the regular random number generator because there's a ton of possibilities here. So often what I'll do, check this out, put some names in here. Suppose I want to randomize a list of names. So Gary, Ruby, Julia, and Beatrice. And I want to put these in a random order. What I do is next to each name, I put a random number using rand, and then I highlight those, all of whatever the cells I need, like Gary was number 1, Ruby was number 2, Julie was 3, Beatrice was 4. What I do is I highlight all of them and I just sort their range. It has a header roll, and I want to sort by the random number. And now they're in a random order based on those random numbers. Okay. So there's all kinds of clever tricks we have for randomizing stuff. I'll talk more about that later. Unfortunately, we are out of time for fun with math. So what have we done so far? Let's see. Let's go back to the home page. Where did I put the home page? Back here. So in checking out the goals for week 1, we've gone over most of what's in the structure of data. What are cases and variables, quantitative and categorical, explanatory and response, asking questions. We've talked about samples and populations from section 2. We've talked a little about experiments and observational studies. We need to talk about those a little bit more next class. And then we're going to dive into doing some statistics with categorical variables. We're going to make some pretty charts and graphs next time based on some categorical variables. So please get the book as soon as you can and start reading it. It's very important in this class that you read the book, check out the lectures, and then do some homework. Poke around with the homework tonight, please. I wouldn't do officially the quiz yet. You can feel free to look at the quiz, but don't start answering it till you've read the book and attended this week's classes. And then hold off on the application until we've done some more work together, because we haven't done enough work, I think, to do the application yet. But definitely start the practice. All right, that's it for now. Have a good day. Do good math. I'll see you all in the near future. And if you have any questions, please hang out.